and lesson 4. We're going to do the first part this time, and then tomorrow we'll do the next part. And so first off, I want to take and do the warm-up. And we're going to do a little bit more because I think that probably at this point you have forgotten a lot of the things about how you can find axis of symmetry from Algebra 1. So we're going to spend a little bit of time trying to remember how we can do it from each of these forms. So this first form is vertex form. So let's look at vertex form. Vertex form is that f of x form that we have there. And that's negative 4 times x minus 3 squared plus 2. And so vertex form tells us where our vertex is. And your vertex is always going to be opposite of this number. So 3, 2. So think back to when we did the absolute value. It works the same as the absolute value. So inside the function, so this one's the quadratic, we do the opposite. Outside tells you your y, tells you your vertical shift up and down. And then I'm just going to kind of cover a couple other things. This, remember, gave us that vertical reflection. And this 4 tells me I have a vertical stretch. Just like it was when we were dealing with the absolute value functions. So a lot of it, like I told you, in that absolute value, all that stuff from there is going to carry over and be a part of each of these other lessons. Now let's work on 2. G of x. This is what's called factored form. And for factored form, this is still your A. That's still that number in front. That's going to tell you if it's going to be any reflections vertically, in which in this case it's positive, so there is no reflection vertically. It also tells you your stretch / compression vertical, and that 2 is a stretch of 2. So that 2 is the same thing as like we had that negative 4 in the previous one. So it tells you the same information. So now let's focus in on the rest. Oh, and I didn't tell you the axis of symmetry on that one. I'll tell you it was at 3 on number 1. So now let's find our vertex. And so if I had a graph, and I'm just going to kind of sketch things here, these 2 points are going to give you your 2 x-intercepts. To find those, all you do is set them equal to 0. So when x is equal to negative 5, so negative 5, comma, 0, and when x is equal to positive 7, so 7, comma, 0. And so I am going to go ahead and sketch those 2 points, roughly. This told me my graph was going up, so that means my parabola would look something like this. The axis of symmetry is halfway between it. It's at your vertex, and I know I didn't do a good job of sketching that, but it should be somewhere over here. The distance here and the distance here is going to be the same. So halfway between these 2 points is the x value of your vertex. And so to find that, you do root 1 plus root 2 divided by 2. And that gives you your x value of your vertex, which we usually call h. So negative 5 plus 7 divided by 2 is your h. And so that 2 divided by 2, or 1. So that value of your vertex is 1 comma something. To find your y, you plug it in. So the y, you're just going to plug it in. 2 times 1 plus 5, 1 minus 7. So 2 times 6, and then negative 6. So 2 times negative 36, which is negative 72. And like I said, this was a really rough sketch, so we didn't have all the numbers, and that's the reason it kind of threw off here. And the axis of symmetry, and I usually use the abbreviation A period S, is always x equals the x value of your vertex. So in this case, for this question, we wouldn't have needed to find all that information, but I wanted to make sure you knew how to.
I'll never make fun of you, Laura.
So let's go on to 3. This is in standard form. And so when we're in standard form, the general standard form of a function is ax squared plus bx plus c. And so in our case, we have h of x equals 4x squared plus 6x plus 1. And so this C always tells you your y-intercept. The A tells you the same things we found last time. It's going to tell you the concavity, if it opens up or down, and it's going to tell you the stretch compression. So in this one, we had a 4 vertical stretch, and we have a 4 y-intercept of 0, 1 from this last number. So that's just information it tells you. Now, we need to find the axis of symmetry, which means we need to find the vertex. So to find the vertex, the x value is negative b divided by 2a, and then you're going to plug that number in to find your y, just like we did the last one. So the x value, which is called h, is negative b divided by 2a. And so negative b, so that's negative 6 in this case, divided by 2 times 4. So that's negative 6 divided by 8, which when we reduce that becomes negative 3/4. And then you would plug that in to find your y value. 4 times negative 3/4 plus 6 times negative 3/4 plus 1. Which when you do that, you should end up with a negative 5/4. And so our vertex is negative 3/4, negative 5/4. But it's asking us for axis of symmetry, so axis of symmetry is equal to x and the x value of your vertex. Now let's think about this. I want you to think on number 1, how many lines can you draw through A? Well, You could draw a line like this. You could draw a line like that. And if I could actually draw through there, you'd actually see these. There are so many different lines you could draw through there. There actually are infinite. How many lines could I draw through those 2 points? Well, through those 2 points, I can only draw one. Now in this next one, I start at A. I can draw a line that goes through C. I can draw a line that goes through B, but I can't cover both B and C at the same time. So therefore, I can't draw a line that goes through all three. So there is no line that will go through all three. And so the minimum number of points you need to draw to have a unique line is 2. So let's think about it through parabolas. Remember, a parabola is the graph of a quadratic. It looks like something like this or like this. We are not going to be working with sideways parabolas just yet. We're just looking at up and down. So we're looking at the functions today. I want you to think of how many parabolas you can draw through point A. Well, we can draw a parabola that opens up. We can draw a parabola that opens down. But we can get inventive. That doesn't have to be on my vertex. I can draw a parabola that opens up over here. I can draw a parabola that goes here. I can draw a really thin parabola. There are actually infinite parabolas that you can draw that go through point A. Now I want you to think about A and B. If I had A and B as my two of my points, how many parabolas can go through both of those? Well, let's see if your parabola that matches my parabola. Did it? Does it match this parabola? Does it match this parabola? It's not supposed to come up. There are actually infinite parabolas you can draw that go through 2 points. I want y'all to think of how many parabolas you can have that can go through these 3 points. You can actually only draw one when you get into the data. There's only one parabola that will actually go through all of those. We can sketch a couple of other ones that may look a little bit different, but they're actually technically only one. There's only one parabola that can get through those 2 points, those 3 points. So you need 3 points to make it a unique parabola. So we've already kind of hit this at the beginning. I didn't want to go through it with just the letters. So I wanted to do it through with numbers. So in standard form, the big thing is A can't equal 0. Because if this was 0, we now have a linear problem. And it's the same thing on all of these. Because if we had an A is 0 here, we'd have it equal 0. If A was 0 here, we'd have it equal K. So A can't be 0, otherwise we're no longer in a quadratic. So in standard form, A will tell us the concavity. Fancy name for saying this will tell me if it opens up or opens down, and it's going to tell me my stretch / compression vertically. Now, that is the exact same thing that is going to be told to me in each of these. So you can just copy and paste that same statement. And unfortunately, y'all don't get the same privilege of copying and pasting quite literally, but that same statement goes to all three. So now, I so now we are going to determine the other characteristics. In standard form, you'll be able to find the y-intercept by 0, comma, your c. In factored form, you're going to be able to find your x-intercepts by 0, or excuse me, by opposite of your root 1, comma 0, and opposite of your root 2, comma 0. And then in vertex form, you can find your vertex by opposite of your h, comma k. Or really it's honestly just h, comma k, but we think of it as opposite when we plug it in.
It always smells good in here.
Okay, so this is going to be very similar, and this is kind of walked through the steps that we did at the beginning to help you go from the standard form to the vertex form, or finding the vertex, and from the factored form to find the vertex. So this is a great page to go back and see each step. I would make sure to highlight and make note of the two formulas that are here, of how you do it. But these two methods are similar because the second step, when you're finding the y value, all you're doing is plugging in. But let's say Kate liked Christine's method and she wanted to use Christine's method. What she must do in order to be able to use Christine's method is she's going to have to convert this over into standard by multiplying it out. So g of x, and so she needs to know what these two will multiply to. So that's using that box. We have x and positive 3 and x and negative 7. And we have x squared, 3x, negative 7x, negative 21. And so x squared plus, minus 4x minus 21. And then multiply that negative 1, or that 1/2 through, gives you 1/2 x squared minus 2x minus 21 halves. But Christine, if she wants to use Kate's method, she's going to have to factor. And if you don't remember how you factor, is you have to go from the inside of the box out. And so step 1, and we're going to go through these one step at a time. You have the 2 x squared plus 12x plus 10, and I need to take out that 2. So 2 is going to factor out of each of these. And then I'm going to use the box. But this time, instead of going from what we have on the outside to create the inside parts of the box, I'm going to go the other way around. And so I'm going to fill in the information. Remember, these two pieces combined to create this 6x. So whatever we put there has to add to give me that 6x. And so I need to think about what two numbers will multiply to give me, and what it needs to multiply to is that 5x squared, and add to give me 6x. So I could do 1x and 5x, multiply those together, that gives me 5x squared, add them, it gives me 6x. It does not matter which spots you put those two things. When I factor it out, I come up with an x here, a 1 here, because an x can go into both pieces. 1 is the only number that goes into both pieces here. There's an x in both pieces here, so that's an x. A 5 can divide into 5x and 5. So that comes out as a 5. And so I come up here, and I'm going to put that as x plus 1 and x plus 5. That 2 that we had earlier still comes down. And so this is it in factored form. Then I want you to look at the back of this section, and you should see these cards. You're going to sort them and match up the equation. So let's say this equation matched this one. You match the equation to the graph. I would focus in on thinking about how you can split them up into two main groups. Well, we have a section of them that open up and a section that open down. That might be something that you pull out. And then only using the knowledge we have now, separate those into two groups.